In this video, we're going to talk about inequalities that involve quadratic functions. So these work a bit different, so let's look at a little example. So suppose we're trying to solve the inequality x squared is bigger than 1. So if we wanted to do this like we did the linear inequalities, we'd want to square root both sides. And we would get the inequality x is bigger than plus or minus 1. Okay, what does that mean? So let's look at them individually. If we think x is bigger than negative 1, well, this can't be a solution because 0 is bigger than negative 1, but 0 squared is not bigger than 1. Okay, so this is in that set, but not a solution. Okay, so then this inequality cannot be the solution set. Okay, so maybe x bigger than 1 is the solution set. But this isn't true either because negative 2 is not in that interval, but negative 2 squared is 4, which is bigger than 1. So it should be in the solution set. Should be in solution set. Okay, but isn't if our solution set is this x bigger than 1. Okay, so what that means is neither of them work to give the full solution. And together they don't work to give the full solution because if we join them, intersect them, then it's actually just x bigger than negative 1. But we know that 0, so this one, should not be in the solution set because it doesn't satisfy the inequality. So that one doesn't work. And this would be the intersection, and it doesn't work either because then we miss some. So this method of doing the same thing to both sides doesn't work if the inequality is a quadratic. Okay, so if it has an x squared term. So it turns out that the quickest way is actually to sketch a very, very quick graph. Okay, very, very quick. So you don't need any sort of very many features on the graph, just a basic shape really. So how we're going to do that is you want to rearrange the inequality so that you have 0 on one side. Okay, so your inequality is going to look like one of these 4. The reason for that is it's easier to compare to 0. So then what you want to do is you want to know where does f of x meet 0. So what does that mean? That's the x-intercepts. So we want to find the x-intercepts and then do a quick sketch of the graph. So basically what I mean by quick sketch is you want to know, does it open up or down? Okay, so if you have the x-intercepts, then you just need to know, so if I have, let's say, an x-intercept here and an x-intercept here, I just want to know, does the parabola have this shape or does it have this shape? Okay, and because I'm comparing to 0, which is this line here, I just need to know where it's above and where it's below. Okay, so I don't actually need to know how high it goes or how low it goes, like where the vertex is. I just need to know if it's opening up or opening down. Okay, so like I just mentioned, if you're looking for where it's bigger than 0, then that's where the graph is above the x-axis. And if you're looking for where it's less than 0, that's when it's below the x-axis. Obviously, if you have your inequalities have the equalities with them, then you want to include the x-intercept points. Okay, now it's possible that a parabola would have no x-intercepts, and what that means is that it's entirely above the x-axis or possibly entirely below the x-axis. Okay, so then you won't have any place where it crosses and you just need to know which. So the solution set is either going to be nothing. So this symbol here we call the empty set. Okay, so that means that there's no solution. Okay, so no x values where the function is always positive or always negative or whatever. Or it's all real numbers, so it's everything. So it's basically if you don't have x-intercepts, then your answer is going to be all or nothing. So let's just do a quick example. So just reading from the graph. So here I have the graph and I can see that there's an x-intercept at -1, 0 and at 2, 0. Okay, so now if I want to know where is the graph strictly bigger than 0, that's all of the points where the y values are above the x-axis. So that's going to be these intervals here. So that's going to be x is less than -1, or x is bigger than 2, or in interval notation we would go from -infinity to -1, not including -1 because I don't want to include where it's 0, and then I would union that with 2 to infinity. Again, not including 2 because we don't want to include where the function is equal to 0. Okay, now if I want where's the function less than or equal to 0, so that is going to include where it's 0, but then it's going to be everywhere it's under the x-axis. So that's going to be between -1 and 2, or in interval notation it's going to be from -1 to 2, including the endpoints, because we want to include where it equals 0, which it does at -1 and 2. Okay, so reading from a graph, once you have the graph, should be fairly straightforward. Especially if you want to be comparing to 0 though, okay? That makes it easier because then you just need to look at the x-intercepts. That's where your function could change from positive to negative. Okay, so in this part, f of x is bigger than 0. Okay, and if you're down here, that means that your y values are less than 0. Okay, and if you're on the line, that's when your y values equal 0. Okay, so that's how you can read from there. Now, if you have two graphs given, and you want the solution for f of x, say, is bigger than g of x, then you want all the x values where f of x is above g of x. Okay, now or similarly, okay, if it's the other way around. So you just want to look for which y values are higher. Okay, so look for where each y value, okay, is higher at a given x value. Okay, so higher means bigger. Okay, now I'm going to leave example 2 for you because we did some that were similar to this in the linear functions section, except they were both lines. But it works the same way when they're parabolas. So that would be good practice for you reading from a graph. Okay, now let's look at example 3 here. So right now I have x squared plus 7x is less than -12. Okay, so the first thing I want to do is rearrange it. So I'm going to add 12 to both sides. Okay, so that I get 0 on the right hand side, because it's always easier to compare to 0. Okay, so now I want to know where f of x plus 7x plus 12 is less than 0. So I want to find the x and y intercepts. So I want to solve where it equals 0. So we could factor this. So I want two numbers that multiply to give 12 and add to give 7. So that's going to be x plus 3 and x plus 4. Okay, so then we're going to have x-intercepts when this factored form equals 0. So that means that x plus 3 is 0, or x plus 4 is 0. So we get x equals -3 or x equals -4. Okay, so that's where our intercepts are. Okay, and then, so let's start drawing our graph here. 1, 2, 3, 4. Okay, so I have an intercept at -3, an intercept at -4. So now I want to know which way does it go. Okay, so does it open up like this, or does it open down like that? And I can tell that because if I look at it in this form, a is 1, which is bigger than 0, right? That's this value here, the thing in front of the x squared. So that means that it opens up, okay, facing up. So that means that my parabola has to look like that. Okay, and that's as much of a sketch as I need, okay, to figure out my answer. So I want to know, where is that thing less than 0? Okay, so it's saying less than 0. So that's going to be in this interval here, where I'm between -3 and -4. Okay, so that's going to be -4 is less, so I'm strictly less than, so I don't want to include 0. So x, for all x's that are between -4 and -3, the y values are less than 0. Okay, so that means that solution in interval notation, the solution set is going to be not including -4 and not including -3, but all the points in between -4 and -3. So that is in interval notation. Okay, now let's do one more. So here I have 2x squared plus 1 is bigger than 0. Now this one, so we already have it compared to 0. Okay, so that's nice. So I want to solve, where is this equal to 0? 2x squared plus 1 equals to 0. So this doesn't factor nicely. And in fact, if you try and solve for x squared, you'll get something that doesn't make sense. Or you can use, so you could also use the quadratic formula. With a is going to be 2, b would be 0, and c would be 1. Okay, so that means that x is going to be -b, so -0, plus or minus the square root 0 squared minus 4 times 2 times 1, all over 2 times 2. Okay, so that gives me plus or minus the square root of -8 over 4. And obviously -8, I can't take the square root of that, so this doesn't exist. So that means that there's no x-intercepts here. Okay, now there's other ways to see that there's no x-intercepts. So this this function, I'm going to write it down here. So y equals 2x squared plus 1. This is actually written in the transformations already. Okay, so it looks like that. So it has not been shifted horizontally, but it's been shifted, so it's x squared, but it's been shifted up by 1 because of this part. And it's been vertically stretched by 2. Okay, but that's not going to move, it's only going to move the y values up higher. So our graph is going to look something like this. Okay, so we can see that it never touches the y-axis, but in fact knowing that it opens up is enough. Okay, so a is 2, which is bigger than 0. So if it opens up and it doesn't cross the x-axis, then it has to be above the x-axis. Okay, so that is enough for that. So now we can see that this inequality, so where is this function bigger than 0? Well, that's everywhere it's above the x-axis, so that's everywhere. So here our solution set, our solution set in interval notation is going to be all real numbers or -infinity to infinity. So this function is in fact always positive. So always, yeah, it's always positive. And I mean, you might be able to tell that right away. So if I square a number, I get a positive number. Times it by 2, I get a positive number. And then add 1 to it, I also get a positive number. So this number definitely has to be positive, which is bigger than 0. So there's 2 more examples. I would like you to try both of them. So I will complete them in a subsequent video. But try your best to, they're very similar to what we've been working on, so you should be able to complete them on your own. But you can, the notes will be posted so you can check your work, and also there will be a video in case you have any trouble.